So my name is Niels Leenheer, and you don't have to repeat. You don't have to try to pronounce it. I'm a Dutch web developer, and I am a browser geek. I also run the 4th largest open device lab in the world, and I created this website. It's HTML5 test, and basically what happens if you visit the website, a whole bunch of feature detection tests are being run, and for every test that passes, you'll get some points. Those points are added up, and you'll get a total score. That score is between 0 and 555. Why 555? It's 555 HTML5 test. Okay. Before I give my actual talk, I want to show you a bit about how current desktop browsers do on HTML5 test. And the top browser right now is Chrome. Firefox is the runner-up. But all of the browsers are 400 points or above. Safari used to be 3rd, but that has changed. But the score is not the most interesting part to me. It's just a number, and who is first and second is actually not important at all. All browsers listed here are perfectly good browsers for browsing for today's web. And the actual results are much more interesting to me. But the score is not meaningless. It can show very interesting trends like this. And we can see that Microsoft actually has done really well since Internet Explorer 6. So, weird browsers. I want to start with a photo. And as I said, I'm a browser geek, and the people on this photo are indirectly responsible for that. And one person in particular. You may have recognized somebody here. That's Steve Jobs. But that's not the one I meant. It's this one. That's Bud Tribble, and you probably haven't heard about that guy before. He is the vice president, or was the vice president of software development at Next. In fact, all of these people are the founders of Next. And back in 1985, when Steve Jobs was still working at Apple, he led a team to create the Mac. He got in a conflict with the board and the CEO, and he got fired from his own company. And that is when he started this new venture, Next Computers. And at the start of the 90s, they released their first computer, the Next Cube, which was revolutionary, far ahead of its time, and also extremely expensive. This one costs over $10,000, and that's 1990s money. Its target audience was education and science. So when I started my computer science education back in 1993, my university had a computer lab with 6 of these 2nd generation Next machines, Next Station, which were lovingly called pizza boxes. And the university had these computers not because of the hardware, but mostly because of the software. It was a Unix workstation. It was based on BSD. It had a graphical user interface. But the most important part, it was completely object-oriented. It uses a special dialect of C called Objective-C. And its development tools allowed us, students, to create quite impressive apps very quickly. And this was in the time the rest of the world was still using Windows 3.1. They were also connected to the internet, those boxes at the university, which was quite unique in the Netherlands, because at that time it was not possible to get an internet connection as just a regular person. The first consumer ISP started later that year. And the internet looked like this. Most of the information on the internet was available on Gopher, a command line tool that kind of looked like the old dial-up BBSs. And you had layer after layer of menus you could navigate and finally download some text files or maybe even some binaries. But after a month or so, a student pointed me to World Wide Web. It's an application that worked, or that was specifically built on Next. And you had a document with links, and you could click on it, and that was the first web browser. The first web browser was created by Tim Berners-Lee, an Englishman that worked in Switzerland for CERN. He was a scientist and wanted to create a method for sharing information on the internet. He invented HTTP, HTML, he invented the web. And if it wasn't for Bud Tribble at Next, just a few years earlier, this probably all wouldn't have happened. Or maybe would have looked very differently. Because it was the next step, next software that allowed Tim Berners-Lee to create the World Wide Web. And many of the features of the first versions of HTML were modeled after the text classes of the Next Step software. And later came Mosaic and Netscape and many, many more browsers. And all of those browsers were pretty weird. They were new and people were still experimenting on what the browser was meant to do. And both users and creators of those web browsers could not have imagined what we now do with the web. We watch television on the web, we do our shopping on the web, we document our lives on the web. And between that first browser and now, we can see all kinds of weird browsers and experimentations. The first mobile browsers were not even capable of rendering HTML, but people tried to get on the internet anyway, with WAP or iMode or whatever. And some of those experiments failed, like this online microwave that you can use to order groceries, or this one. But sometimes there is this device that will change everything again. And it was the release of the iPhone that made mobile internet usable. And it sometimes looks now we use the internet more on our phones than on our computers. And we no longer build special websites for these weird little devices. This is the new normal. And this little device that Steve Jobs here holds in his hands is a direct descendant of that Next Cube that Tim Berners-Lee used to create World Wide Web. And it uses software that is still based on that very first version of Next Step that Bud Tribble created. But the experimentation is not over yet. The web is still evolving, sometimes in big steps, sometimes in small ways. And, well, I'm Dutch. There's a 1 hour time difference between England and the Netherlands. So technically I'm from the future. So I'm gonna show you what the future looks like. So are there still any weird browsers left? Well, there are some candidates. We have game consoles or portable game consoles, smart TVs, e-readers, smartwatches can have browsers, photo cameras, even cars can have browsers. And this is a picture of the dashboard of a Tesla Model S, which has a touchscreen and a browser built right into it. And I do have quite a lot of devices in my Open Device Lab, but unfortunately not a Tesla Model S. So if there's anybody from Tesla here in the audience, we do take donations. But we can't look at everything. I'm going to look at 3 things today. And the first one I've grouped together. It's smart TVs, set-top boxes, and console browsers. And I've grouped them together because they're all big screen browsers. The first problem we're going to run into is availability. Because how do you test your site on multiple big screen browsers? Because most of us only have one smart TV at most. So I went to the Mediamarkt, which is the Dutch equivalent of Currys here in the UK. And I asked them if I could test their smart TV browsers. And well, then they looked at me funny. And after some convincing, they walked over to the drawer, handed me 5 remotes, and I was allowed to spend the whole afternoon at Mediamarkt. And from that day, I can say television browsers are actually pretty good. Well, they use the same rendering engines as mobile operating systems like Android or Firefox OS, which is now unfortunately dead, or Tizen from Samsung, or WebOS. And compared to last generation of smart TVs, this is actually quite an improvement. And we can see that on the HTML5 test scores, because the current generation also scores above 400 points, just like desktop browsers. And we can compare it with the previous generation, for example, LG WebOS with LG Netcast. We can see quite a big jump in standard support. If we look at console browsers, we can see an even clearer difference, because there's quite a slow turnaround with game consoles. And even the current generation is already pretty old. And so we can see the scores are a bit lower than smart TVs. Well, not entirely true. The Xbox One now has Edge, and it brings it into the future. One other thing I noticed when using these smart TV browsers was that they actually don't have that much memory. This happened quite a lot. And their CPUs are also pretty slow. It's better than before, but it's still not optimal. What I'm going to do now is show you some of the differences between regular browsers and big screen browsers. And one of the biggest difference is together one of the biggest challenges, because navigation, how do you navigate without using a mouse or a touchscreen? Well, you can use the D-pad, for example. It's a bit like the arrow keys on a keyboard. It's called spatial navigation. You basically move around the page by pressing left, right, up, down, and the focus shifts to the element that is situated right next to the current element. And so you can use a regular keyboard to emulate this. And what you have to do to make this work is actually to make sure that all your elements that you want to have as a navigation element, to make them accessible. You have to use tab index if you don't use links. And just adding an on-click handler isn't enough. But it can be worse. You could also be moving the cursor with arrow keys on the screen, and usually in very small steps, so navigating is very difficult on some televisions. Luckily, there are alternatives like analog controllers. This works a bit like the red eraser head in the middle of an IBM ThinkPad keyboard. You can move the cursor around pretty fluently, or you have remotes with trackpads built in, or you have remotes with air mouse, which works a bit like a Wiimote. You point it at the screen, and if you move your hand, the cursor on the screen will follow your movements. And after browsing for 10 minutes or so, your arm will fall off. And we have second screens. That's a second screen right in front of you. So my first thought was, why bother browsing on the TV anymore? You already have that screen right in front of you. Well, perhaps it's to show something to other people. I don't know. Many manufacturers also create apps for controlling the smart TV. Again, why not browse right on the phone itself? And the second challenge is, how do you input text on the keyboard? Okay. Again, we have the remote. We can use a D-pad. And that's very clumsy because you have to enter the text letter by letter by letter by letter by letter. And that's extremely irritating if you have long URLs. Luckily, again, we have alternatives like remotes with a full keyboard. And people used to laugh at Google for their enormous keyboard remotes for the Google TV. And they compared it with the simple and sleek and minimalistic D-pad of the Apple TV. But for text input, this is actually way better. And you can use just a regular wireless USB keyboard. You can plug in that keyboard right in many television sets or game consoles, and it works perfectly. Sometimes even the built-in trackpad in this case. And again, we have apps. And there's one other special way of navigating on some televisions or game consoles. That's gesture control. I tried this, and I made a little movie of it. I'm going to demonstrate it. I'm going to try to mimic the exact same movements I did when I created this movie. Okay. First you have to put your hands up. Then it has to sense something. Right. Well, that's not really going that well. Again, after about 5 minutes, your arm will fall off, and yeah. Can we control these input methods directly from JavaScript? Because we have mouse events, we have touch events, we have keyboard events. How about D-pad events or gamepad events? They might be useful for HTML games, for example. Well, the D-pad, well, maybe. We don't have D-pad events, but we do have keyboard events. And a remote control is basically nothing else than a keyboard with some strange keys on it. And this actually works, mostly. There's one thing you have to take into account, because the key codes that are sent back to the browser can differ between manufacturer and model. Now, up, down, left, right, that's probably not a big problem, but if you have some more exotic keys, well, the menu key on one model may output a different key code than the menu key on a different model from the same manufacturer. So that's maybe an issue. Also make sure to use prevent default, because otherwise the browser may think you're pressing that key and the television software will kick in and actually show the menu of the television instead of letting the browser interpret the key. The gamepad, again, maybe. We actually do have an API for that. It's called the Gamepad API. And it can just get all the current connected gamepads and just look at the state of every single button on that gamepad. And this works, but only on the Xbox One. This API does exist on other systems like the PlayStation 4 or the Wii U or WebOS, but that gamepad array is empty. No matter how many gamepads you connect to your Wii U, that gamepad array is empty. So it works maybe. On the Wii U, actually there's a different API, the Wii U's own API that does work, but not every manufacturer has its own API for this. And even on the Wii U, why would you want to use this API if you have the regular API, the official API for it? So why do they support that API, but why is the array always empty? And why does this work? I don't know why this happens, but this is a theme that happens again and again with these weird browsers. Stuff doesn't always work. The webcam is also a form of input, and again, maybe. We do have an API for it. It's the Get User Media API. And the only one that supports this is, again, the Xbox One. So, yay Microsoft. All the others either don't support it, or just like the Gamepad's API, doesn't return any usable streams. Again, why would you support this API if you don't return any streams anyway? Okay. The second difference, the difference between a television and a monitor. There's a thing called overscan. And due to historical reasons, televisions will not show the borders of an image on the television screen. And a browser built into the television itself isn't affected, but any device connected to HDMI is. So what happens? The television enlarges all images by 5%, and then crops the image, and the borders fall off. This is a problem because, first of all, it causes blurry output, and that is clearly visible if you look at a browser on a television screen. And, well, the second problem, the borders fell off. So, if you have any content in the borders, that is quite a problem. There is a solution, luckily. It's called overscan correction. So we can add a black border around the content. That black border will then be chopped off and the content is still visible. But not every television set enlarges by exactly 5%. And this can actually vary between manufacturers, but also between models of the same manufacturer. So most devices allow you to configure the correct overscan correction in the system preferences. And this is on a PlayStation 4. And you move the white arrows to the corners of the screen, so it knows how your television is using overscan. Of course, there's always a problem, because we just configured overscan correction on the PlayStation 4, but once you enter full screen mode, it will still just chop off the borders, because the browser on the PlayStation 4 does not listen to the system settings. Yeah. Luckily, there's a solution for that. Why not turn off overscan? Most televisions allow you to disable overscan, and it's called screen fit or pixel perfect or just scan. And well, just think of your parents. Do they know how to do this? No. So most people don't have this configured properly. And even if they do have this configured properly, you could use the PlayStation 3, for example, which always shows overscan correction, even if you disabled it. And so the PlayStation 3 always uses overscan correction, and the PlayStation 4 never uses overscan correction. So you can't do this right. Okay, I need to explain the viewport for a bit. And I know some people who give a 40-minute talk about the viewport, and they still have enough material to talk about. This is complicated stuff. I'll try to do it in 2 slides. We have a visual viewport, and that determines what part of the site is visible. And we have the layout viewport, and that determines how the page is rendered. 2 slides. The default value of the layout viewport is equal to the width of the window on a desktop browser. On a mobile device, it's usually fixed. It's usually 980 pixels. But on a television screen, this is a different story. Default layout of viewport is different on every smart TV, console, or set-top box. It's somewhere between 800 pixels and 1920 pixels. And as you just saw, the layout viewport changes the rendering. So the rendering on all of these devices is different. Well, it is possible to change the width of the layout viewport using the meta viewport tag. And this works perfectly on mobile. And instead of the default 980 pixels, you can set it to the width of the device or your own value. Complication. Is not supported on smart TV browsers. So we just have to deal with our beautifully designed responsive websites that look different on all television browsers. An added complication, device pixel ratio is also not supported. So if you have a smaller layout viewport, every CSS pixel consists of multiple device pixels, just like your iPhone, which uses 2x images. We want to use also 2x images on those televisions. But that does not work because device pixel ratio is not supported. So if you have a small layout viewport, you'll get blocky photos. This is how websites can differ. And it usually is somewhere between 800 and 1920 pixels, but that can make quite a difference. And this is a list of all the devices I tested. And the width is, well, all over the place. And something else to consider. Device pixels aren't always device pixels. Sometimes device pixels are not physical device pixels, but virtual device pixels. The browser usually renders in a lower resolution and upscales to the resolution of the display. And that's quite logical in some ways because, as I said, the memory on these devices is limited. So it doesn't have enough memory and enough CPU power to render on a 4K display. It just uses HD resolution and then upscales. Or some Android TVs use 720p and then upscales it to HD. Or the Wii U uses the resolution of the screen of the gamepad. And the PlayStation TV is actually a PlayStation Vita without a screen. So it uses the resolution of the screen of the Vita. So doesn't always make sense. Next difference, the distance to the screen. Usually, we sit about 20 inches from our screens, but we don't sit 20 inches from our TVs. That's actually more like 10 foot. So, the Internet Explorer for Xbox One developer guide says this: make fonts and graphics on the site larger to account for viewing distance. People sit proportionally farther away from a television than from a computer monitor of the same size. So we need to make our text and images 2 to 3 times bigger. And that makes our sites look completely different. This is, for example, the YouTube website on a television. It's completely different from a website on a desktop computer. And this makes it actually usable on a television. So we need to use the opposite of responsive design. We need to adapt our layout to the viewport. We need the same layout on different viewports. And we can do that, but it feels like going back in time a bit. We can use percentages for positioning, because 50% of a small viewport is just as big as 50% of a large viewport if you project it on the same screen. This actually works pretty good. And we can base the font size on the viewport using a clever hack, or we can use viewport units, which are supported on modern smart TVs, and maybe older ones with a polyfill. And of course, we need to make sure there's a safe margin around the contents, because, well, people screw up their overscan correction. So how can we apply this to our website? We need to identify our smart TVs so we can push some specific CSS to their browser. And luckily, there's a media type for that. Very simple. You can just say media, TV, and the television specific styles. But that doesn't work. All television browsers use the CSS media type screen, just like phones use screen and not handheld. And that makes actually CSS media types in this case useless. Well, we could look at the screen size. Perhaps that works? Well, no, it doesn't. Because monitors and phones often also use HD resolutions. So this code will actually trigger on smart TV, on phones. And smart TVs often use other resolutions, like I just told you. They might be using 720p, or the resolution of the gamepad stream. So this will not work. We can use user agent sniffing. I know it's a dirty word, but if it works. No, it doesn't. Not all smart TVs are actually recognizable. This is the user agent string of an LG Netcast television. It's Safari on Linux, somewhere in Korea, and that's about it. The only reliable way to do this is to offer a secondary website, or maybe a couch mode, a button which sets some cookies, and if you click on it, the page is reloaded with those cookies, and then it sends some other CS. Yeah, it's a mess. Another difference. Be careful with feature detection. Basically, every feature that talks to the operating system or the hardware is suspect. We've all seen that with the Gamepads API in Get User Media. Basically, every feature that talks to the operating system or hardware is suspect. That's what I just said. For example, geolocation. This code is pretty simple. Actually, just forget about that. This code is pretty simple. It's feature detecting geolocation, and if it's present, it gets the current position. There are 2 callbacks, success and failure. How can this go wrong? Well, first of all, failure is called with a permission denied error code. And that's actually makes some kind of sense, because we can handle this. It's not pretty, because if they did their jobs correctly, the browser vendors would have just turned off geolocation completely. But we can handle this. But what if no callback is called at all? Then the browser just waits and waits and waits until it gets a callback, and nothing happens. So we need to set a timeout and code defensively for this kind of stuff. But there are other ways this can go wrong. For example, success is called. Yay! But with coordinates 0, 0, which, as somebody told me recently, isn't necessarily wrong. It's just very unlikely that the user is in the middle of the Atlantic Ocean. But the 4th way this can go wrong is actually almost comically wrong, and it happens on the Google TV. Not the Android TV, but its predecessor, Google TV. It has a Chrome browser, and if you call get current position, it returns the coordinates of Google's headquarters in Mountain View, California. Yeah. So, is there a future for web apps on the big screen? Well, Apple just released the new Apple TV. It has a proper SDK based on iOS and has an app store, so this is a big opportunity for big screen browsers. But the new Apple TV does not ship with a browser by default. It does not even have a web view. Well, that's not entirely true. It has a web view, but it's not a public API. So you can't use it and distribute your app on the App Store. And also, you can't build one yourself, because the rules of the App Store prohibit making HTML renderers. So no browsers on the Apple TV. But Android TV also does not ship with a browser by default. And they do have a web view, that's a plus. And you can actually install third-party browsers. And many television manufacturers that use Android TV actually ship a version of Opera. But it's still a worrying trend. So, are big screen browsers going to make it, or is it one of those failed experiments? I don't know. The second topic of today, e-readers. E-readers are pretty bad. It's to be expected, because they usually don't have audio and no video, and so compared to regular browsers, the scores on HTML5 tests are a bit lower, and sometimes quite a bit lower. So what are the differences between regular browsers? The infrared touchscreen is one big difference. And you may have heard of capacitive touch or resistive touch. What is infrared touch? Well, around the screen you have infrared LEDs and sensors. And when you put your finger on the screen, it blocks the ray of light between one LED on one side and a sensor on the other side. So it knows where your finger is. And that actually works pretty good, except that the resolution is pretty low, because you have to have physical sensors for every pixel of resolution. And also, once that ray of light is blocked, it can't detect any additional finger. So this matters for mouse events and touch events. If you have a Kindle or a pocketbook, you have limited mouse events. Mouse down and up are triggered at the same time when your finger is released. So you put down your finger, nothing happens, and you release your finger, mouse down, oh, mouse up. Okay. The Kobo actually has separate mouse down and mouse up events, so that's a good thing. They actually also support mouse move. And the Sony Reader actually supports touch events. Limited to one finger, okay, but it supports touch events. Except that one is not for sale anymore. So the best one, well, you can't get it anymore. The other difference is e-ink screens. And it's technically a lot different. Yeah, it's more complicated than this. This is just the basic technology. You have small microscopic balls with pigments, and you have electrodes. And when you apply a current, those balls will change their orientation. And then when you lose the current, the balls stay in the same position. That's good, because that makes it very energy efficient. But it's also very slow. It's extremely slow. You have to see it to believe how slow it is. So I created a little movie. Yeah, so maybe those CSS animations and transitions weren't such a great idea after all. Another difference is that two completely different colors can look exactly the same in black and white. We have 16 shades of gray. So, yeah, which one was green? So how can we identify these e-readers and give them special CSS? Turn off the animations and change the colors a bit. We have CSS media queries, monochrome. It doesn't work, no. All e-readers I tested actually act like they have a color screen. The browser doesn't know it runs on a black and white screen. The transition, the conversion to black and white happens in the display controller. So media queries aren't going to work. And the only thing that kind of works is, again, user agent sniffing. And There is no universal marker or token in the user agent string. So we have to look at individual models and manufacturers, and yeah. Also not a lot of good news for e-readers. The last topic is portable consoles, and a little bit more advanced than these ones. There are actually two families. There's Nintendo DS and there is the PlayStation Vita. And the PlayStation is actually not interesting at all. It's too normal. It's basically just a browser on a mobile phone. But the Nintendo DS is pretty special because it has two screens. But again, it's surprisingly normal. It's having a dual viewport is not that weird. Just slide from one viewport to the other. And the only tricky thing is maybe with position fixed, but they actually support that also quite good. And it works a bit like this. Well, nothing weird. So, at the beginning I asked the question, are there still any weird browsers left? And I think the answer to that is definitely yes. I want to leave you with a very inspirational quote from Jason Grigsby. We cannot predict future behavior from a current experience that sucks. And I sincerely hope he is right, because the current experience definitely sucks. But wait. Let's go back. Weird browsers. We talked about weird browsers like they are something special, but they're just browsers. And when we create our websites, we don't know what our visitors are going to use. Some of our users may be visually impaired and use a screen reader, and some may use their mobile phone, and others may use an e-reader or a game console. And the web isn't a single platform. The fact there's a multitude of different browsers is inherent to the web, and that's what makes it great. The web is for everybody. And a lot of the techniques that make the web more usable for these weird browsers are techniques that actually you should already be using to make your web pages more accessible. Making pages accessible isn't just for people with handicaps, it's for all your users. So this talk wasn't really about weird browsers. It was about assumptions that we as web developers make and expectations that we have. And that these assumptions and expectations may sometimes be wrong or too limited. And if there's one thing I want you to take away with tonight, is the web is more than just Chrome, Safari, or Internet Explorer. Thank you. If there are any questions, we can do maybe a couple, and otherwise just we can go to the pub and drink a beer. Yeah. Am I a fan of correctmode.org? Yeah, I am. PPK is a good friend of mine, and his work is immensely useful for us web developers. But he focuses more on the more common browsers and mobile phones. And I think some of these weird browsers are a little bit too unknown for some people.
Can I give you a...
Now, I know you've mentioned a bit about responsive websites, and in some respects they don't always quite work as normal. One thing you haven't mentioned is a fact about websites where they look at the headers. So if you're on a mobile, go to whatever website, where you get a completely different website,
Yeah.
a bit similar to WAP in a way, to www. Is that something that you for or against, and why as such?
Well, for television browsers, it's actually the only way websites will work properly. And even big names like YouTube use a different URL for their television site.
Like
So
like m dot something, or
yeah, similar to that. And now for most websites, that is completely over the top, and just trying to make it a bit better looking and trying to make the navigation a bit more fluent is enough. But for a website like YouTube, it's absolutely essential. It works optimized for television. And yeah, having a second URL for the same website on a different platform isn't pretty, but if it works, yeah.
yeah, it comes to like loads, page loads. I think that's the biggest thing I was thinking about when it comes to separate.
Yeah.
Thank you.
All right.
Any other questions?
Oh.
You mentioned sort of, consoles, TVs, and maybe sort of the obvious ones, but are there any examples of like devices or things that you haven't mentioned in the talk that are maybe a bit too weird for this that you have tried? Like, I don't know, like a fridge or something weird?
Well, I think these were already pretty weird, but yeah, there are some devices I haven't mentioned, but it's most of those devices were sold 10 years ago in Japan. And it's hard to get a hold of them. And how relevant are they for today? But there are some pretty weird things. And I wish to look at some of the car browsers if I can. But so far Tesla hasn't called me yet. So. All right,
Anyway,
let's go drink a beer.
good move. Right, well, thank you very much again, Niels.